For example 2, we want to find the critical points of f of x equals natural log of x. So a basic function. I'm going to follow the same steps we did in the last example. Let's take a look. Step 1, take the derivative. Again, critical points involve the derivative, so the first step is to take the derivative. F prime of x, derivative of natural log of x, is 1 over x. Pretty simple. Next step, set the derivative equal to 0. Okay, so natural log of x is going to be, the derivative 1 over x is going to be equal to 0. You can already see some issues here, okay? This will never equal 0, right? I mean, 1 divided by x can never equal 0. We can cross multiply and see that if we did 0 times x equals 1, it's never true, okay? So when we solve for x, there is no solution. Now, the second part of the derivative of critical point is determining the x values where the derivative doesn't exist. We can quickly see that if we set the denominator equal to 0, which a lot of times is what happens when you're finding critical values, we will get x equals 0. So x equals 0 is a critical value, but we talked about before that it might not be a critical point. So what do you need for a point? Well, you need a y value. So step 5, we will write out all of our critical values, but when we go to plug it back into the original, natural log of 0 doesn't exist. Okay, we know because e to whatever power you put will not give you 0 back. Therefore, there are no critical points. There is just a critical value. Critical values may not yield critical points. Here's the graph of natural log of x, and I need to put some arrows here. But we can see that there are no values, or for horizontal tangent line, there are no values where the derivative doesn't exist on the domain of natural log of x. Now at 0, there's an asymptote, but that's not part of the domain of the function. So this illustrates that just because you have a critical value doesn't mean you have a critical point. That's it for this example. Natural log of x has no critical points, just a single critical value. If you have any other questions about this, let me know.